So every time when you see me run the program, you know that you also probably doing this as well. So we go into our terminal and manually do like ifconfig and choose the interface name. So if example, like if we type ifconfig and the manual interface name is, my name is eth0, your may be vary, like you may have like ylen0, ylen1 or something like this. So if you just type ifconfig and our interface name to check to see if our MAC address got changed to the value that we request from the program. So what I want to do is I want to add functionality to our program so that at the end of the execution it will check if the MAC address did actually change to do what the user asked to do, or if something went wrong or something like this, and then the MAC just did not get changed. So in order to do this, we need to come up with a very simple algorithm. So what I mean by algorithm, which is that it is a number of steps that allow us to achieve our goal. So in our goal in this here is to check if the MAC address got changed to the MAC address that the user requested. So we are doing this at the end of the execution of the program, and to come up with the steps that we need to take, all you have to do is you need to think what we do as a human. So when we try to check if the MAC address got changed, we open a terminal window and we type ifconfig and check if the value of the ether got changed or not. So if we want to get our program to carry out these steps, we are going to have to first execute and read ifconfig. And so far we know how to execute system command using Python, but we don't know how to read out the output. So we need to able to read the result of ifconfig, and also we are going to need to read the MAC address from the result. So once we read the whole result of ifconfig, then we are going to need to filter out the result to only this part of the result, which is ether, MAC address of the part, and the only part contains the MAC address. So then third, we are going to need to use an if statement. So decision making to check if the MAC address is what the user requested, and finally print an appropriate message, say either that the MAC address got changed or the MAC address did not got changed. So now we are going to apply everything that we learned so far in order to achieve this, and also we are going to learn new concept as we go through these steps, and we're going to talk all of those steps one at a time, and as well as we are going to carry those steps, and we're going to forget about our general goal. So we're going to forget about the fact that we want to check if the MAC address was changed, and we want to go to our step 1. Then we're going to focus on our solve the simple problem. Then we're going to step 2, we focus on solving the simple problem, and then at the end we're going to see how everything clicks together. And so the bigger problem which in checks if the MAC address got changed or splitting the bigger problem into a number of smaller problems which are easier to solve smaller problem, and then at the end once we solve all of those small problems, there will be a big problem, and this is going to be very simple and trivial. Now the first step or the first simple problem that we need to solve is being able to execute system commands and read the result, because so far we learned how to execute system command using subprocess.call function, but that allow us to execute commands with that seeing the result right now. So we are interested into running ifconfig, but we want to see the result that ifconfig returned to us. Now if you do a quick Google search, or if you look through the manual of Python, you are going to come up across with the subprocess module again. And this is actually the same page that contains the subprocess.call function. And if you literally search or just scroll through, you will see, as you can see in here, this is a function that allows us to execute system command just like subprocess.com. So this is the only time subprocess is going to check the output as the name and suggest that this will return the output that will return by the command. So when you use this function to run, if config will actually get the result of that, and if config return will be able to capture that and use in a variable, and then it will print and it will modify it and do whatever you want with it and our program. Now you can see there is an example of how to use this function in here, and if you see the way that is very similar the way that we use the subprocess.com. So you have a list, each element of a list is a word, and in a word that command that you call and it will get processed at subprocess or process dot and check output, which is this one. So let's go ahead and write this in our program. Let's minimize this. Now I have my program in here, and I'm just actually going to click this minus here beside the function name, and this will allow me to hide the function code. The function code will not be deleted. I am just pressing it to hide this. As you can see, you can minimize it. It just makes easier for us to focus on what you want to do. Now I'm going to write my code. I already wrote my code all in here. Very simple, as you can see, only 3 lines. So let's tell you about how this code actually is doing in here. So before I do that, this is the line that actually changed the MAC address. So but there is, so I'm just going to do is, or I'm going to add option is equal to get argument. So now what you interest is in the first one, which is check output. Now once we press that, we are going to get a description of, as you can see, all of those, how to use this function, and but we actually know how to use this, and it's very similar to subprocess, which are very familiar. So with all of that, we know what we want to do is we need to use two square brackets in here, followed by a list and the comment. So we want to run if config followed by our interface name. So it's literally if config followed by interface name. So let's say I run it like it is 0, and if you type line 0, it will run our script, and this is going to be the if config, and the first element between the two quotation mark, which will be the if config, that we will put, and then we put a comma and put a second element, which is option.interface, which will be the interface name. So anything that comes after a space and our second element is the interface. Now we know in our program that the interface is captured to get the argument using the option, and we use it the same way that we use it to checkmark function by doing the option.interface. So all I have to do is just put option.interface in here in my second element. Now we are going to enclosing this between the two quotation mark, because this is a variable that we want Python to know, because this is the variable. So that is a substitute of the value that start the variable so far. Very simple. So after that, just we are going to print this if config result, and it will execute and it will be all fine. So after the execution, check the output will return the result that it config returns. So usually how do we write on if config, it will eventually result by running this Python code. So we actually have to capture that result in a variable. So you can call the variable anything you want, but because I like to use meaningful names, I'm going to call it if config underscore result. So I'm going to say that this should be equal to subprocess.check output and putting the command of if config then the interface. So when you execute this command, it will, so let's execute command because you need to use -i to use our interface, then -m. So as you can see, this gives pretty much similar the same result, but is, I think there is some spacing problem, that's why it's showing all horizontally. But as you can see, it's easily the same. As you can see, flag 23, broadcast running, multicast, MTU 150, then your inet, then your net mask, and all of those is just showing in vertically, not horizontally. So we are getting the interface in here, and when you execute this, so we should see this result similarly that we see in our if config command. So let's now try to work in a different things in our next lecture. Now that we have the first simple problem solved and we are able to execute and read the output of system commands, we can move to the next step, which is the reading the MAC address from our output that we got. So if we go back in here and look for our program that we run, which we can see that the output that we are capturing and if config result is the output of the effort, which is all of those text in here. Now all of those are not interesting to us. The only part that we are interested in is the MAC address, which is this. Which is the part in here. So we need a way of telling our program to ignore everything and only read this part. So if you read the highlighted part, which is the MAC address, now the MAC address are the method that I'm going to show you that you can filter anything that you want, but we are just going to use this for an example. So let's copy all of those. What happened? What happened? All of those. Okay. So as I was saying, I'm only interested onto this part. So now we're going to look at the thing that you can read this highlighted part, which is my MAC address. So the method I'm going to show you that can be used to filter anything that you want, but you are just will be using this as an example. So if you are building a program, you might want to filter something else from these different texts. So it doesn't really matter. So I'm going to show you a very powerful way of being able to search and look for interesting piece of text within a large text like this. And what we're going to do is going to use to do, and we're going to use this all of those. So these are all and these all are same. So let's copy this and go to our Firefox, and I'll show you a way that you can differentiate. a regular call regex and go to this website. This is called Pythex, and paste all of those in here. As you can see, you pasted all of those, and we press regular expression cheat sheet. So it basically allows us to define arrow or a pattern, and then Python or whatever programming language you are using is going to search throughout this text for the pattern that you specify. So let me show you what I mean. So after pasting all of those, so this is the special characters. Like if we put dot, so if we put dot in here, as you can see, it copies or it matches all the result or all the text. So as you can see in the match in the result, we copy all the text. So like if you want to identify a number within this all text that you paste, then what you have to do is you have to go and look for the special characteristics, and then go for, like, let's go for backward D. As you can see, backward D means all the numbers. As you can see, all the numbers from this text corresponded to digits. So in my rule, if I put backward D, you will see it's gonna match anywhere in the text that has contained a digit. So if you are writing code that needs to use any of this digit, then you will be able to use this rule and find this digit. Now, how to implement these in Python, I will show you all of those in our next lecture. So for now, I just want you to have a general idea of what this regex is and how to write rules for regex. Now same goes for anything that you are looking for. For example, let's say you are looking for anything that comes with greater or lesser in here. So what we're going to do is we're going to say that I am looking for something that starts with a greater and a smaller between these two things. So I don't care what's in here. So let's type dot. As you can see, it's not dot. So as you can see, it pitches nothing, and if we put slash, also nothing. So if I put slash dot, okay, slash, also nothing. So this matches nothing. But the thing is, like that I previously talked about, we are interested in this. So how can I define this MAC address specifically using these rules or these expressions? So like you can use minus W for non-alphanumeric. So as you can see, these are the non-alphanumeric numbers which are in our MAC address. Also a couple are in here for inet. So let's type slash W. As you can see, it selected all of those. If you type again slash W, as you can see, it also type all except for numbers in here. So puts colon. So as you can see, what colon does, it specify the non-alphanumeric number, but we just want to have this number. We just want to have all of those MAC address in our expression. Using expression, we just want to select all of those. So what you have to do is just copy all of those and paste in here. As you can see, you are nearly here, and I think, as you can see, by just simply typing slash W using non-alphanumeric number, it finally selected or matches the result only the thing that we want, which is the MAC address. So it highlighted the MAC address, which means that I can use this regex rule in my code to guess of what programming languages what you are using. You can use this rule in your programming languages like this. Yeah, like you can find other rules. As you can see, there are lots of rules you can do. It just, so if you want to check IP address, then you can check rules similarly like this that we did. So, and if you have a text like this, the program in programming language will able to do as much as part of this text which is interesting to us and which is the MAC address that we want to check. Now, like I said, regex and a lot of things that I'm teaching you in this lecture apply to all programming and languages. So the differences is going to be the syntax, but the ideas and the concept and the way that you build the program is always the same. So now once you know how to use regex, you are then able to write or use any programming language that you want, and you can use any expression to search any match, anything like this. So it doesn't have to be like Python, but since this is a Python lecture and Python course, and also in the next lecture we will be showing you how to implement this in our code, and we're going to be working in our variables in here, which is the if config result that we showed, and we will learn how to stack this MAC address from all of these texts using the rule that we just created. So now so we know that what regex is and what we actually build will allow us to match the MAC address from the result of if config. So let's see how we can implement this in Python and filter out the variable so that MAC can be only shown in result in if config result that will give us the full result of if config. So I already did this part, which is a pretty simple 2-line. So now we're going to see how we can use this rule in our code, which is this rule. So we are using this rule, as you can see in here. So we are actually going to see how we can do that. Now to do this in Python, we can use a module called re. So just simply import re. So which is stand for regular expression, and you can use the same rule that I just show you. So let's go ahead and start implementing this right away. So first of all, we need to import the module. So just import module, import re. Then this module we need to use this sub process. So simply just type. So in order to do this, we are going to do read, which is the name of the module re. So which is, as you can see, this part. So I will talk about this part later. So let's talk about this part. So re dot search. Then we are using the expression that we received for verifying or just simplifying or a result that will show only the MAC address in our Python code when we run, and then the in config result which are we going to print. So in order to give a Python program a regex rule, you first tag then use quotation mark. So you have to use first R, then use quotation mark. So under the quotation mark, use the regex rule. So then and then at the end, if config result. So after that, what you need to do is you need to print this. So after that, we need to search is equal to MAC address underscore search result. So this is equal to MAC address result, which is equal to the search, and if we want to print this result, we're going to say print MAC address result dot group 0. Basically, or usually it means that if there is more than one string, then this will be placed into a number of groups, and you can iterate through them by saying 0, 1, 2, 3. Now we are interested in the first occurrence, and usually they will be the one anyway. So we will only print the first group or the first result. Now let's go ahead and run this code. So this is the make changer. So let's go to our terminal. So let's search for, as you can see, Python. Just type Python code -i2 is the interface -m, then this. So what this will show is, as you can see, after using this regex rule, it will show you only the MAC address. As you can see, the MAC address that are in here, it shows simply like this in here, with simply using 2-line and a regex rule. So now we are able to achieve the main goal of our algorithm, which is to able to execute if config and read the MAC address. So you can use any rules that you want. If you want to check flags, then you can use rules to flags, then you copy these flags or rules in here, then run the code, then this will simply show flags in here. So that's how you can do this and read different things. So in here in our code, we did for the MAC address rule, so it only showed a MAC address. So the next steps are usually easy, because all you have to do is check if this is MAC address is the target person and which is the target person looking for, or then print the appropriate message. Okay, now that we have a variable that holds the value of a current MAC address, so to finish the first step, we need to finish the second step, and all you have to do now is check if the value and the variable is the same as the MAC that we user entered in an argument. So if it is, then the program did its job and the MAC did change. Otherwise, we're going to say sorry, we couldn't change the MAC. Now there is a 2 steps actually, which is really easy, and you should be able to implement them and using what we learned so far. I will be doing that in the next lecture, but for now I just spend my last 5 to 10 minutes to simplify our codes and make it look nicer and more readable. And although, as you can see, these lines are at the end, and we use a if else function. If something goes wrong, then it will see could not read MAC address. As you can see, we just simplify our code and nothing else, and just in here we just add one line. So we'll talk about that later at the end. But as you can see, we just use a function which is called get current MAC, which is the interface of our connection or wired connection. So pretty much similar code that we previously do. So what this full code will do is, so previously when we run the code, as you saw, the code runs and the result got all of those information, like, so previously it showed all of those information also, then the MAC address at the end. So as I was saying, so it showed all of those, and at the end in here it showed the MAC address that we use for regex. But this code, what this code will do, it simply just show you this MAC address and nothing else. So that's the part that we do, simply just to simplifying our code and just removing couple of the lines to make it much more pretty and simpler. So let's talk about this line. So the idea of printing something as a something else or treating a variable as another type of call casting and programming. So what we're doing right now in here, telling Python that whatever value of the current MAC address has, I want you to treat it as a string. So if this function is successful, then it will be able to get me the MAC address, and we know the MAC address already going to be the string anyway, so this will work just fine, and otherwise will not be we're not going to get anything. So this function will return none if this is wrong. So but I am telling you to treat this not object as a string. Now the result that will go around in our code with this is, first of all, it will say it may run with ETS 0. So let's run this code. Python MAC changer, as you can see, so it will simply show this MAC address and not all of those results. So let's see if this works or not. As you can see, current MAC is the string that you're using, and this is the current MAC of our Linux machine. So we are successful of writing our code. So we have a function to get our current MAC address, and this is very handy for us as we can use it in the future anytime that we need to able to get the MAC address. Also, it makes our code much prettier and easier to read, and also it will allow us to use the function multiple times with the code. So you can see we have already using the function in here just to print the current MAC address, and then later on the lecture we are actually going to see how to use this, and we're going to get the current MAC address again, and we're going to check if the current MAC got changed to the MAC that the user requested. So if we didn't do this, then we would have to use this code twice in the program. First to print the current MAC address, and then second to use it to validate if the MAC changed. So we have to use the code couple of times if we use our previous code. That's why we just simplify our code, so then we can use our code one time in our next lecture to finalize this. So now that we refactored and cleaned up our code, we are ready to go ahead and done with the next two steps, which is first of all check if the current MAC address of the MAC the user requested, and then print the appropriate message. Now we are going to combine these two steps in this lecture because these are very easy, and we actually used everything that I'm going to do now in the past, so it should be easy for you to understand. Now first of all, I'm just going to hide all of those, because right here we don't care about this, because we know this just that we have a function and this gives us the current MAC, and right here we have the code in our main program, and we know now this current line right here is going to get me the argument and the user that enters, and the next line here is going to get me the current MAC using the current MAC function that wrote in our previous lecture. Then we're going to print the current MAC, and then this is the steps where the MAC address is going to change. So I am actually going to do is just use this. So this is the code where interface and option change MAC will apply. So this is the line where this will call the function, and it will send the option that interface and option with new MAC, which is the interface and the MAC that the user enter as an argument. So far so good. After this step, the MAC address should change to the MAC address that the user requested. So if everything goes smoothly, so after this line we need to check if the current MAC is actually the same as the MAC that the user requested. So Now to do this, we need to get to the current make again. So this is the current make. So this line we have to write again. This is the similar as this, as you can see. So this line is identical with this line, and both line will do the same thing. They just get the current make. And keep in mind, I am just using the same variable name in here, which means that whatever value that was stored in the variable before will actually get changed. So now the MAC address did not get changed. Now that we have the value of the current MAC store and the current MAC variable, all we have to do is use the if statement, if else statement. So in the if statement, we just use the current MAC is equal to get current MAC, which is this one, and then after that we just print that MAC address was successfully changed to this, and then else MAC address did not get changed. So one thing that I want to note here, to see in here, I actually use equal in here. As you can see, current make equal instead of a single equal. And Python, when you are comparing two values, and so we are comparing the current make and the option document. So we are comparing the current make. So if you want to check if two values are identical or equal to each other, then you have to use equal instead of a single equal, because as you see, before you use a single equal, Python thinks that we want to assign a value to the variable. For example, when we want to capture the value of an argument, we set option equal to get argument. What we want to capture is the current make, which is the value returned by the current make function. So we say current make equal to current make, get current make. So if you don't want to change the value of the variable, so you just want to check if the value and the variable is equal to the value of the variable, then you have to use equal instead. Now that's it, our code is done. So let's go ahead and test this. So I'm going to go to terminal and run our code, and you will use my 22 at the end to change the MAC address. So change the MAC address to ETS0 to something that will end up with 22. As you can see, our MAC address, current MAC address was this, which was, as you can see, this. Then changing MAC address to this, and then we change our MAC address to this. So let's check if I successfully change or not. As you can see, our MAC address is changed, and this program works perfectly. So if it faces error, it will going to print error message to us, similarly like this, did not get changed. So well, is working, and is giving us the message to validate that everything works fine, and it also looks good and is very reusable because we split it into a number of functions. So we can call this function multiple times throughout the program. One thing that I want to advise again, note that the value here in the current make, which is current make this. In the first time it was printed as a actual make. So previously, as you can see, it was printed as a actual make, and then we printed as actual current make, then we changed to this make, and then after change successfully changed to this make. Since the make got changed and the value in here overwritten with the whatever the function returned, so if you check it again, you will see that it's printing to us the value of the make after it got changed. So these just show us how you can override the value and variable as you go along throughout the program. Now that's it for the program. I am happy enough with it. We cannot still add more feature to it, but I think that's good for now. As we learn how to use function, we learn how to use decision making, we learn about regex, we learn about modules, we learn about how to execute system command, we learn about dictionary, we learn about list, and all of those. So we learn how to use module. and also read system output and much more throughout a simple program. So we are done with it. So next, we'll move on to another program where we're going to learn more concept and build more stuff. Thanks for watching.
Hello everyone. Let's talk about MAC changer for changing MAC addresses. Changing MAC address with MAC changer in Linux, there is some command like a media access control. MAC address is a unique number that gets assigned to every network interface, including Ethernet and wireless. It's used by many system programs and protocols in order to identify a network interface. One of the most common examples would be the case of DHCP, where a router assigned an IP address to a network interface automatically. The router will know which device it has associated assigned an IP addresses to by referring to the MAC addresses. Unlike an IP address which is temporary and can be changed easily, MAC addresses are hard coded into a network interface from the MAC changer. However, it's still possible to change or spoof a MAC address temporarily on Linux systems. One of the easiest ways to do this with the MAC changer command line program. There are both legitimate and shady reasons for a for why a Linux user may find the need of change a MAC address. In this tutorial video, you will learn how to install MAC changer or major Linux distros, how to identify current MAC address and network interfaces, how to change an interface's MAC address, how to change interface to a specific MAC address. Install MAC changer on major Linux distros. To install Mac Changer or on Ubuntu Debian and Linux Mint, the command is sudo apt install Mac Changer. To install Mac Changer on CentOS, Fedora, Alarm Linux, and Red Hat, use Mac Changer to change any interface's MAC address, and the command is IP. Before we start using the Mac Changer command, you will need to know the name of the network interface that you want to work with. You can execute the IPA command to see a list of available network interfaces on your network system. You can begin a change the MAC address. Follow along with the step by step instructions below to see how not you will need root permissions in order to execute the Mac changer command. Step 1, use the -R option to get a random MAC address. In addition, just specify the name of your network interface. Command is sudo MAC changer enp0s3 to output should show your current MAC address and the new one that has been assigned from MAC changer. Step 2, to verify the change, try running IPA command again, and you should see the new MAC address listed. Step 3, if you need to use a specific MAC address, you can do that with the -m option and following command syntax as sudo messenger -m b and address. And step 4, various vendors have different MAC address prefixes. Therefore, you can easily identify the manufacturer of a network device by looking at least first few bits of MAC address. This means we can use MAC changer to make our device look as if it belongs to a certain MAC changer. To see a list of known MAC addresses and their corresponding vendors, use the -1 option. To do this, first you need to be rooted in terminal in Kali Linux. And give command if config and some network running multicast broadcast flags. Some information is show. Then write command if config wlan 0. Help and GNU Mac charger uses Mac changer's options for device. There is many options. Use Mac changer to change an interface MAC addresses, like use the -r option to get a random MAC address. To verify the change, try running the IPA command again and you should see the new MAC address listed. If you need to use a specific MAC address, you can do that with the -am option and the following command syntax. When you need to when you know the name of the network interface that you want to work with, you can execute the IPA command to see a list of all the available network interfaces on your network system. In most cases, this will include a wired wireless and loop hack loopback interface. We saw how to change the MAC address of a network interface on Linux. There is done through the MAC changer utility, which can be easily installed from the default repos of most major Linux distributions. We also learned a few different options to use with the command in case you would like to have a random MAC address, a specific one or one from a particular vendor. So if you do this in your Linux terminal without root, it gave so much error. So guys, that's it for Mac Changer. Hope you guys liked it and thanks for watching.
Previously, we learned what ARP is, how it works, and how we can use it to discover all the connected client on the same network. And this lecture, I'm going to focus on building an ARP spoofing program. Now, ARP spoofing program, program was to manipulate to and also to redirect the flow of target. So instead of it flowing, as you can see in this diagram, it would flow through my own computer. So any response sent and any response received by the target computer will have to flow through the hacker computer. This means that my message and your website and image and username or any password entered by the target will have to flow through my computer. So this allow me to read the information, modify it, and then drop it. So as you can see, this is very serious and very powerful attack, and the reason why it is possible is that because ARP is not secure. Now, for us to understand how this works, you need to have a basic understanding what ARP is, and I covered that at the start of our previous lecture. But if you don't remember how ARP works, let's just talk about briefly. But basically, ARP is used so that the client can identify other connected clients on the same network and get their MAC address, because as I said before, client connect with each other with the same network using the MAC address. So each computer have an IRP table and which link the IP address on the same network to their MAC address. So if I go to let's go to our Kali Linux machine, and if I just type ARP A, sorry. So ARP. Sorry, for some reason it wasn't showing the result, so I just fixed it. As you can see, previously it wasn't showing anything, now it's showing. So as you can see, it's linking to the router IP address. So this machine, anytime it needs to send any request to the internet, it will direct that request to the MAC address. So this is the MAC address, this is the router address, and this is our connected client, as you can see. So it will direct the request to this MAC address and to the MAC address, so that the associated with the IP of the router, which is this one 192.168.1.1. Now this value in here can be easily modified by exploiting the ARP protocol. So let's just go to, okay, let's also try on our different machine to see what this ARP tool shows on different machines. So let's try ARP minus A. As you can see, gateway and also two different MAC address on different machine. So let's also try on our Windows machine. As you can see, this is our dynamic vision, this is our router IP address. So let's go back to our diagram. So we have a diagram of a typical network. So you can see that normally any device that connected to the network, if it wants to send the request, it will send them to the router. So there, then this will go and send the request to the internet, and then it will wait for the response and then forward the response to the device that requested it. So if the hacker or victim or any other computer on the network wanted to send a request, they will send the request directly to the router. Now what we can do is we can exploit the ARP protocol and send to the ARP responses. So one of the gateway and one to the victim. So and we're going to tell the gateway that I am the IP of the victim. So the access point will update its ARP table and it will associate the IP of the target with my MAC address, and that will do same with the victim. So we'll send it a ARP response and we're going to tell it that I am attending this 192.168.1.1, which is the router IP address as we previously see, and it's going to update, and the ARP table is associated with the IP with my own MAC address. So the result of this is that the victim is going to think that I am the router and the router is going to think that I am the victim. So anytime the victim wants to send the request will then go and flow through my computer and I am going to forward them to the router. And then anytime to access the point or the router that will send responses, they are going to go to my machine because it thinks that I am the victim, and then I am going to forward it to the victim. and then this all puts me in the middle of the connection, man in the middle connection, and it gives me so much power, and we'll see all of that we can do. So once we become the man in the middle, now the main reason we can do all of this because ARP is not secure. Because first of all, client cannot accept responses even if they did not send their request. So as I said before, we are going to send the responses to the access point under the response to the victim, telling that I am the I have a I am a specific IP without them asking who I am, or without them asking for this IP. I am just going to send them the response, and then they are going to accept the response. So anyway, not only that, but there is also not going to verify, they are not going to verify who I am. So when I say that I am at that IP, which is this is going to trust and believe this. So even though I'm clearly not at this IP, because the access point of this IP, so these are the two main weaknesses with ARP protocol that allow us to run the ARP spoofing attack. Now that we understand the theory that behind the ARP spoofing attack, it should be easy enough for us to implement it using Python. But before we get into writing our own ARP spoofing tool, I want to spend just one lecture showing you how to practically run an ARP spoofing attack. So just give you an idea what we want to achieve. Now we didn't mix comes with a number of tools that allow us to run an ARP spoofing attack. So there is a tool called ARP spoof, and using this tool is very easy. It is pre-built in on Kali Linux machine or any Linux distributor, or you can just simply install this. We will also show you how you can do that. So all you have to do is specify the interface that we want to run this attack through, and in my case it will be on ETH0. As you can see, I am on ETH0 because so as you can see, just simply download install this. It will give you access to this ARP spoof tool. So the interface I am connected is ETH0. So if I do just ifconfig, you will see that what interface you are connected to. So we are going to do is you will just type ARP spoof, and we are going to do is -i, which is our interface, which is ETH0. Then we are going to do is -t to specify the target, and my target is this one because this is the target IP address is this Ubuntu. Okay. As you can see, 104. It is also the target IP address, and that is my gateway IP. And as you can see in here, this is the spoof of target, and telling him that I am the victim. So we will need to run this command. We will need to run this similar command in also another, just open another terminal. As we are going to see, use -i to interface, -t to specify. So in this here, we are going to first specify our gateway, then our attack machine. So we are going to telling the router that I am the victim. So first one will fold the victim, and second one will fold the router. So keep in mind that this attack will work against both Ethernet and Wi-Fi or wired network or wireless network. So I'm doing it right now against a virtual network which has as an internet or wired network, but this attack can be executed exactly the same against any wireless network. So all you have to do is connect a wireless adapter and then just calibrate and connect the adapter to the target network and then simply use it. So the same concept as for the network scanner that will apply. So you need to have a wireless adapter that works well with Kali Linux, and you need to have that adapter connected to the Kali Linux and then connected to the target network. So just I'm going to just press enter. Now the computer is not a router. So this is actually the MAC address. So let's just go and type ARTA. As you can see, the MAC address is changed because this is actually the MAC address of our victim machine. So right now this Ubuntu machine MAC is the router, MAC address is the router of the MAC address, and every time you need to center the request, it will send to that MAC address, which means that they will send the computer right in here. So this computer is not a router, so when it gets connected, it actually going to stop them from flowing, and this is going to go to the router, and this is a security feature in Linux, Kali Linux. So you need to enable the port forwarding, and so that is the computer when that would allow packets to flow through it to the router. Now to enable the port forwarding, we going to do is just type echo. So this is the port forwarding process. So echo 1 net IP version IP underscore 4. As you can see, IPv4. As you can see, this command get executed with no issue, and right now this computer will still have its internet access, so we can go and visit any website. As you can see, this computer has still active internet, and it is has internet access, so we can go and rise up any website that we want. But all of those requests are not going directly to the router, but they are going to this computer first, and then this computer is forwarding them to the router as we saw in our previous diagram. And when this response is come back, they are going to go to the hacker first, and then they go to the victim. So now ARP spoof is a pre-built tool that comes with Kali Linux, so we will not be using it from our cases from these lectures. What we want to do in this lecture is to build a program that will run this attack, and that will run that attack for us. So what I want to do is I want to build a program that will run this attack exactly like ARP spoof did right in here, so that we can redirect the flow of the packet and fool this computer into thinking that we are the router. So once we're done with this program, we're going to build more on it, and we're going to see how we can inject code to the browser of the target, then how we can still the username, passwords, and see all the information that the person sends and received, and then replace the download files and throw trojans and much more. We'll learn also all of that in here. We know that in order to become the man in the middle and exploit the ARP protocol and redirect the flow packet so it flows through our computer, so we need to send ARP response to the router and to the target computer, and when we send it to the target computer, we pretend to be the router and we tell the router that we are the target computer. So on this time we're going to learn how to create an ARP response using Python and send it to the target so that we can poison their ARP table, and that will put us in the man in the middle connection. So as you might already guess, we are going to be using escaping. Now I have already created a project which is ARP spoofing, and I'm going to import the escaping exactly the same way that we did in our previously. So import escapee.all as escapee, and then we are going to create our own ARP packets. So we are going to say that packet is equal to escapee.arp. So we are going to say that the packet is equal to escapee.arp, and between these two brackets we are going to set the fields as I said already, but let me briefly describe what you need to do. So we are going to set the field on these two brackets. So now, like I showed you before, you are not sure what fields that you need to set, like what is this field, what is this field, what is this field. So we can just set that in hello everyone. So in this lecture we're going to be talking about bypassing the HTTPS. So far we know how to become the man in the middle, and once we are in the man in the middle, we learn how we can read all the data that's being sent. So we being able to read the username and password, and also like URLs, images, or anything that the people browses, and then we can also able to modify this data. So we are able to inject the JavaScript code or any types of code that we want in the target browser. So when the target browser website, so this also allows us to replace the download and do many cool attacks. So now everything that we does or can do will only mostly work on HTTP pages. The reason why it works against HTTP, because as we see in the data and the HTTP is sent in a plain text, so it's a text that human like us can read and understand. That's why when we are demanding the man in the middle, and we are able to read this text, and if we wanted we will be able to modify the text as we wish. Now this is obviously a problem, and this problem was fixed in HTTPS. So as you know, once website these days all uses the HTTPS, and all good website like famous website uses HTTPS. The reason why, like I said, because it is more secure version of HTTP. And basically the way it works, it keeps all the implementation of HTTP exactly the same. So all the headers, all the way that the data is sent is kept the same. So the HTTP is not modified, but it adds another layer of our HTTP, which is what the S comes from. So the secure HTTP protocol and this extra layer will encrypt the plain text data that HTTP sends. So if a person manages to become the man in the middle, and they will be able to read this data, but this data will be gibberish and that will not be readable to the person that intercept in the connection. It's only going to make sense that the user and the server, because they both have the same key and are able to decrypt, and they can able to decrypt the encrypted data. So let's have an example what this would be look like. Now in general, when we became man in the middle, we'll use the ARP spoofing or any other method. As we know, the request will flow through the hacker, and the hacker will forward this to the internet or to the access point. Then the internet and then the response will flow through the hacker computer and then down to the victim. Now usually if a person or user tries to go to a website, and let's say for an example they try to go a website like bbc.com, and they will send their request. Now this request and this initial request will not be sent over the HTTPS unless the user types HTTPS, because before the website, as we all know, most users include in myself, like we don't really type HTTPS in our website URL. We just simply type our user website name like bbc.com, and they will like this they will also type bbc.com. So the initial request is going to send over the HTTP and the hacker being demanded, so the man in the middle is going to receive this and forward it to the internet. And bbc.com to the other hand is going to respond by saying like, hey, why don't you talk to me over HTTPS? It's more secure now that the target knows that the BBC can communicate over HTTPS, then they are going to communicate with BBC using HTTPS from now on. So other questions that will follow after the initial request will be sent over the HTTPS, and the hacker will receive these forwarded and will be forwarded and to the internet again as HTTPS. The server wire responded with HTTPS, as you can see. Now the communication with other requests, other under responses are sent over the HTTPS. Now like I said, HTTPS adds a extra encryption layer to the HTTP protocol. So this will mean that the plain takes the data which will read in HTTP, and that will be encrypted and it will not useful for us. So now that we are man in the middle, we will able to see all the data and we will be able to read it, but this data would be like as well gibberish and it will not be readable, and therefore we won't be able to see the username, password or URL on the HTML codes. So we want to be able to inject a code or modify these packets because we cannot even read them in the first place. Now this is really bad for us as hacker, because we did all the hard work of trying to become the man in the middle, and once we are in the man in the middle, we are not be able to get the use of this very good position. So there is a smart guy called Maxi who has been defeating SSL for a very long time, and there is one of the ways that these guys come up with that allows us to bypass the HTTPS and then get it to HTTP. Now the Maxi didn't only discover this attack, he also wrote a great tool that will do all of this for us. So the way this is works is, let's have a look. similar. So let's have a look in this, and this is the initial request that we said, and usually people don't type HTTPS when they request a web page. So they will type, for example, bbc.com, and this will go through like hacker computer, who is always ready and already demanded the model and which is also running. So a tool called SSL strip, which is the tool that implements the attack. Now the tool is going to see that this is the HTTP request and it's not going to play with it. So this is good for us as hackers because it will just forward it to the internet. So next, bbc.com is going to respond by saying, hey, why don't you come with me with HTTPS? Now SSL strip is going to detect this, and by the way, when I say that, it's going to say when you don't communicate with me over HTTPS, the process is actually a little bit more complicated than this. So I'm just keeping it simple as possible. So the SSL strip is going to detect that the server is trying to tell the target to communicate over HTTPS, and it's going to remove or strip all the fields and all the data. That's basically saying that let's update this connection to a HTTPS connection. So the response is going to come as a HTTP response. But SSL strip is going to strip that and only forwarded the part that looks like a normal HTTP response to the victim. Now, so far the victim doesn't know the server can communicate over HTTPS, therefore it will send and the next request as a normal HTTP request. Now here's where SSL strip is smart, because it's going to keep track of all the websites that have sent the HTTP response. So even though the victim is going to send the HTTP request when it's communicate with bbc.com, the SSL strips that bbc.com likes that will communicate over HTTPS. So what's going to do is, once it get to the HTTP request from the victim or the target, it will actually upgrade that connection to a HTTP connection. So as far as bbc.com is concerned, it told the target that you should communicate with me over HTTPS, and the target responds by starting the communication with communication over HTTPS. So this is the perfect for bbc.com, and for the victim as far as concerned, they don't like bbc.com that can communicate over HTTPS, because every time they send the HTTP request, they are getting the HTTP response. So they don't think that we busy can communicate over HTTPS, because if it can, then it will respond to the victims saying that the communication with me over HTTPS. Now this configuration is perfect because as a hacker we are able to read the request under responses as a plain text, and nobody knows that we are playing around with that connection. So the target takes all the website that we are trying to accept on your support that HTTP, and the web server is also happy. Also because it is communicating over HTTPS, and what they think is their client. So but who are communicating with is actually us. So now we are able to be here and we can actually get HTTP response from the internet. So we are actually able to read them because we are the one that initiating the HTTPS requests. So you can see that the HTTPS cycle is actually only between us and the internet or the web server, and not between the victim and the web server. Now the another thing that SSL strip will do when it loads the web pages, it will actually convert all the link of the web pages from HTTPS to a normal HTTP. And this way, when a SSL strip is working, all the HTTPS connection will be done and graded as HTTP. So since the connection are going to be downgraded to HTTP, this means that the data is going to send as a plain text, which means that we will be able to read and modify the data. So just like usually how do we do HTTP, now there is an exception for this whole rule, which is a website that you use HSTS. Now HSTS is used by Facebook, PayPal, Gmail, and for example basically The way this works is the browser at the victim and the target comes up with a hard-coded list of websites that it should only load as HTTP. So even if we try everything that we can try and to download this connection to HTTP, the browser will just simply refuse, and it will refuse to load this page because it knows that the page has to load over HTTPS. Now so far there isn't a practical way of bypassing HSTS, but there was, and that got fixed, but I will update you when as soon as a new way to bypass it. I am only going to show you how to use the SSL strip with all the tool that we're gonna need. Now let's, as you can see, I am on my Kali Linux machine. So the first thing what we need to do is we're going to make sure our IP tables does not contain any rules. So let's just open terminal and let's just going to, so we're going to do the IP table flush. So just type IP tables flush. So as you can see, it instantly did this. Then the first thing I'm going to do is become depending. So now the next step is to run the SSL strip, and to strip all you need to do is just type SSL strip, because SSL strip is a built-in Kali Linux tool, so you don't need to do anything. But if you use any Kali Linux that are previously like old version, then you just simply type apt-get. So simply just type apt-get and just type install SSL strip, and it will simply just install SSL strip. But as you can see, SSL strip is already pre-installed. So remember, when you are creating tools that modified the package, such as the tool that replaced download and then they told that they inject the JavaScript code, so we had to redirect those packets to a certain places where our tools was listening on. So using a net filter queue now as a SSL strip, so let's first just type, as you can see, SSL strip on Moxie, the owner is running. So basically SSL strip is actually runs on port 10,000 by default. So with the analysis packet that pass through like port 1000 or anything else, this tool will ignore all of those other than this 10,000 ports. So that what you need to do is you need to redirect any packet that comes to my computer on port 80, which is the port that is used for web server. So we're going to redirect all those packets onto port 10,000 where SSL strip is running. Now as you know, we usually do this redirecting using IP tables. So let's just open another terminal. So let's just now type this is the line. So let's just describe what this do. So basically you are redirect all those packets on port 10,000. So we want to modify a table that called, so we are going to type IP tables, then we're going to minus T for tables, then net and minus A. So dash capital minus A, and this is the rule is going to be the pre-routing rule. So it's a rule that applies to a packets and that comes to my computer before the computer makes a decision on where this packet should go. and these rules will apply to TCP packets. As you can see, this will apply to TCP packets. So, and that packets is going to be port on destination 80. So as you can see, so basically the packets that are going or coming from a server or web server, that we want to redirect these packets onto port, and this is going to be port so 10,000. So we are going to redirect this 80 port to this port, and which is the port is on SSL strip is running by default. So now that we, so simple, just press enter. As you can see, it's working. So this will run without showing any error, which means the command got executed correctly. Now the last thing that you want to do is run the tool that you want to do. So you can run a sniffer to reduce the name and password. So you can run a program to replace the files that we did previous lectures or previously, or run a program to inject the JavaScript code or any other program that you want to run. Now to keep this simple, I am just going to run the sniffer, and I am going to do a python package sniffer.py. Okay, sorry, I didn't locate my package sniffer. So let's just open terminal here. So this is my Python code package sniffer, and this is the directory of our Python project. So let's just type Python package sniffer. As you can see, it is running, already running, as you can see. So now keep that in mind that I am already in the working directory of my package sniffer. So if I just run, it will work. So let's just show you what this Python package sniffer does. So this is the actual code. So let's just see. As you can see, pretty simple code. What this will do, it will sniff all those packets, and it will get all of those credential into my terminal using this package sniffer. Pretty simple. So let's minimize this. Let's minimize this. So this is the all three that we need to do. So now it's going to happen is that if the target goes to a website that uses HTTPS, and SSL strip is going to downgrade the HTTP connection to a HTTPS connection to a HTTP connection, then the packet sniffer is really unaware of what happening is in the background. So it's not data that goes over the HTTPS. Since SSL strip is downgrading the connection to HTTP, then the sniffer will be able to read the data and plain text just like any other website. So let's go and test out on our test website. So let's just reload this web page. So as you can see, it is on our now connection is on HTTP. So let's try our, as you can see, connection is not secure. This will, so if you are putting in a password in a HTTP page, this will show up like this connection is not secure. So it has nothing to do with our attack. It will always be displayed actually. So let's try. As you can see, it is already running. Not this one, not this one. As you can see, it is a requested HTTP request on those website. So let's type any username like Akash at the rate, sorry, okay, at the rate gmail.com, and our password will be 123456. So let's do save. So if you check, as you can see, possible username and password detected, and that the password I put akash@gmail.com, and the password is 123456. So if you are going, if you are new to this thing that we really need in, so this lecture is basically to use the SSL strip, which downgraded the HTTPS to something that we are used to, and we tested our code which is HTTP. So they entered that and they will be entered the HTTP, and that will going to be encrypted and it will send to as a plain text, and that's why our sniffer is going to be able to read this data and print on a screen. As you can see, all of those on website will be able to get you this result. As you can see, the page is also loaded PHP, GIF, all of those information in here. So that's how you sniff using the packet sniffer and SSL strip. Okay, now that we know how to use SSL strip to downgrade HTTPS connection to HTTP, and we see how can we use that on our simple sniffer. So now I want to spend a little bit more time to show you how to use SSL strip with the programs that will be modifying the packets, such as a program that will replace the downloads and the program that injects the codes into the browser. The reason why I want to spend a little more time with this program, because using them with SSL strip is a little bit trickier than using SSL strip with a simple sniffer, because this program will modify the packets with SSL strip that will also modify the packets. So we will have two programs running at the same time. Both will try to modify the packets. So you need to know how to run them properly so that they don't interfere with each other. So let's go to the terminal. I already worked on too many, so this one. So you can see that I am already run couple of the comment, and I have already running the SSL strip, and I have already run the IP tables rule for SSL strip, which he will redirect any package that's going to this port. So this will go to port 80 to the port where SSL strip is working, which is 10,000. Now we also know to order. So in order to use our program that modify the packets, we have to redirect packets using IP tables. So on the forward chain to the queue that use in our program. So for example, in the replace download program, we run our, so this is our replace download net filter queue. So this is our replace program, replace download Python program. So for example, in the replace download program, we use the IP tables to place the packets in the queue so that we can analyze them in our program. But now, since we already run this rule, which is the pre-routing rule, this rule will redirect all of those packets that's going on the port 80. So going on the port 80 to SSL strip, and there will be nothing, and nothing stored on the forward. So there will be no packets in the chain, and this chain will be empty. Therefore, if we run this tool, so basically these two commands will redirect packets leaving and entirely my computer to my program, and the p-writing rule that we were going to use is actually going to redirect all the packets on the port 80 to SSL strip. Now this is also one more thing that we need to modify on our program, and I already did modify is, so if we go here and if we check the destination port, so this destination port should be, so d port means destination port, this should be 10,000 as the port of SSL strip. Then this is a request, so if the source port is 80, so the packets is coming from will be 80 baht, where as you are using SSL strip, so in 80 there will be 10,000, in here also source port will be 10,000, because every time we get a request we have a IP table rule that in redirect this request to the port of 10,000. So the deport in our packet is actually going to set to be the 10,000 instead of 80. Now the same is whenever we get a response, and this will be 10,000, we will be redirect to this port. So the export and this response packet is actually going to be the 10,000, both export and deport, these two. Now that means that the target is leaving SSL strip, so it's going to be in this direction, and therefore again this packet is going to be the SSS HTTP packets and send and play the text. Therefore I'll be able to read it and modify it, and whenever I modify it will be delivered to the target. So with these changes done, my program is ready to be used and it's compatible. Now the SSL strip with both HTTP and HTTP websites. Now there is actually a small bug that I did fix, is in here, and basically it looks for the download and the downloadable files. If it detects something that downloaded in exe, as you can see in here exe, we will replace the exe file, that the file we have in our server, which is, so if we go to our server evil file, as you can see, why it is not working. Okay, let's wait a bit. So okay, so as I was saying, let's go to and check it out in manually. So this is our server directory, which is in var www html and evil file. So this is the evil.exe. So as you can see, this is the file. So that's where it's an URL in here which is called evil.exe, and if you notice that here evil.exe itself is an executable file which is exe. So depending on the way that the target website works, this might cause our program to be stuck in a loop, because this will request another exe which will be detected in here because we are checking. So if the request contains the exe, so this exe will be replaced with this exe. So the downloadable file, so these pages you will download the exe, this will replace to our this exe, which is this file. So it will replace to our this file. So what we did here is, we simply literally do is, if request is not the evil file, so we know that our evil file is hosted on my web server, and that's called this our evil web server. So if I just copy this web server, as you can see, this is the same website as the same website web server. So saying that if exe, and if the request that I want to modify is give my evil file, but I'm also going to add this condition, which is and this is not in escape packet. So I'm going to say that my evil URL or my evil server is not in my escape packet. So then escape.raw and load. So you can think of this as a book that fixed to our program. So it's nothing to do with HTTPS. It's just something that makes our program more reliable and work against more websites. Now that we're done, just save this and just run this program, and just it will work fluently. But as you can see, I cannot really load any pages right now. I cannot really demonstrate this part because maybe my internet is down. But the thing is that when you run this code, so as usual, So you have to run this both command lines. So and then you have to just simply run the command that we did in our previously, and it will show all of those in also in here similarly like this that we did previously. In all, just simply what you have to do is run the code which is our replace download code, and it will just simply replace the downloadable file on your website to your exe file that you selected in your program, which will be replaced by this exe file. So when you click the download, it will allow me to download this evil exe file, which is my fake file or my file, instead of the website's download file. So but the thing is, it will doesn't look like proper Trojan, but we will address that later on, and I'm going to show you how how to make this file look and function exactly like any other exe programs that the target person will be expected and even will be able to download like PDF or any image file, and that will be covered in our future lectures. So now we'll just focus on replacing download and the program that we did and that perfectly. Now just to make sure that the download that we got is not broken and it will work, and this is actually the credential harvester that will send my password to this computer to my own email address. And this code, if you run all of those properly, this will just execute all of them perfectly, and using that method you can just replace any file, not just exe. You can just replace in here or in your evil file directory. You can just replace PDF, image, song, any file that you want, not the file that the target person downloaded from any website. So if the website uses HTTPS, and that's how you use code and sniffer and SSL strip to replace the download file. So now that we are able to replace the downloads even if being downloaded from the HTTPS pages, let's see how we can use the code injector or inject codes or modify codes and HTTP pages. Now this is going to be very similar to how we did previously on our replace download code. So, and again everything I am doing now is generic. So basically if you manage to get this to work, you will be able to modify any types of code and HTTP pages, not on the codes that I am showing you. But first of all, I have my code injector programming in here, just like I did with my previous all like package sniffer, replace download, spoof and all of those. So now I'm going to modify those port, which is those 10,000, as SSL strip always uses those port as 10,000. So again, because that's where the cell surface is going to be working, and it's going to strip them and send them to do that port. So if you go down and turn on our terminal, so let's open terminal, and so if I run the input rule, which is the IP tables, so the rule was this one. So if I just run the input rule as previously I did, and the output which will take places on the packets even coming to my computer into the account, so which is the queue where my program is going to analyze the packets, and we have already executed this rule which will redirect to my packet 80 to about like 10,000 where SSL strip is going to work. So everything so far is identical, so what we did in our previously. Now I am already in my code injector, as you can see in here. So if you just simply run this code on your Python, and so far this is the thing that will need to do is you need to modify the port that we set is 10,000, because the port where SSL strip is working is on 10,000. So if you just run this code and go to the website, like any website like hotmail.com, you will see that your code is executed and it will pretty much will work out of the box. So now all you have to do is now say is like we are going to say this load is going to be equal like in here code. So make sure you all type this code currently. This is the simple one. So if you go to this any website like WinRAR or wingy.com, all of those websites that uses HTTP, and you will see that the page will open normally and your code will also get executed. So this way this code will work fluently if you just type all of those currently and use all of those rules. So then after that all of this you will be able to inject codes then HTTP pages that were able to modify the codes, and you will be able to replace download as previously that will show, and you will able to sniff the data as very first time we show you how you can sniff the data. So basically everything that we are able to do on HTTP pages you can do on also on HTTPS pages. Okay, so now my goal in this lecture is to write a program that can detect when a user requests to download a certain file, and when we detect that request we will serve a defined file. This defined file can be a backdoor, a keylogger, or any other file that you want. So what you have to do now is you have to just write a couple of codes. So I already did this. So now I'm just gonna explain how this works. So in the first line, as you can see, which will convert the packet to escape packet, which we are going to need to obviously modify. And then the next line you can see there is a line, if the current line has a DNS RR layer. So when someone downloads a file through the browser, the request and the response is sent through the HTTP layer, not through the DNS layer. So the check in here is we need to check if the current packet contains the HTTP layer. Now you can skip the HTTP library that I showed previously, which will work great when you want to analyze and print data on a screen, but when it comes to modifying the data, it will actually make our code much more complex. Therefore, in this lecture, I am going to show you how to manually filter packets that contains a HTTP layer and categorize the packet as request and response, so that we can further analyze these packets and then use this information to modify the packets and achieve our goal. So the first thing I want to do to check right here, instead of checking a DNS error response, so I want to check if this packet contains a HTTP layer. So I am still not sure if it's a HTTP response or request, but if packet contains a HTTP layer with useful data, it will contain that in a raw layer. So basically the way that CPU works is it has main layers, which are the IP and the TCP and the UDP, and then finally at the end it depends the raw data such as HTTP data in the raw layer. So to check if a packet contains this layer, all you have to do is just type raw in here, So then we can print our packets. So we can print, so we can print escape packet, and this will print all the packet that contain useful HTTP data, because as I said, escape data sent in the HTTP layer, so our place is in the raw layer. So if you run this, just this code alongside with this print as escape packet, without this we will talk about this later. So if you just run this code in a Python, this will just if you go visit any website like bing.com, so and you have actually run the IP tables or in there to redirect the request and response to the program. So I actually show that how to do that, so I'm not gonna do it, so I'm just gonna explain how this will work. So what it will do is it will print the packets that contain HTTP layer with the useful data, and the useful data is actually will be in the raw layer. Now in the packet is actually not so useful, so it is compromised, and we will talk about this later. And when you run the code, you will see that we will have a packet, and you will see that they will have a layers like IP layer or TCP layer, or then in the end it will be like raw layer. Again we will have the useful data that we can read and then plain text. Now this is great. So what are you gonna do then? You are gonna filter only the packets that contain the useful HTTP data. Now I want to talk about more right now, because these packets are we are not sure which packets are requested and which packets are responses. So I want to able to differentiate between the response under the request, so that I can understand what's happening when we click a link or when we download the file, and then what to be able to build our attack. So we know that there is a request, because we can see there is a get method or get request on this specific site that you will open like bing.com. And if you look at TCP layer, you will look that in the deport field you will see that it says HTTP deport, and deport means destination port, and this means the destination port of the packet is a HTTP port. So using this S port, which is means source port, and the deport, which is mean destination port of the TCP layer, we can determine whether this is response or request. So if the default is set to HTTP, then this means this is the destination in a deport. So either it's going to be a HTTP port. So but if the port is S port and set to HTTP, that means the packet left from the HTTP port came right into us, which means that this is a response. So we can use a simple if statement if our code is so what you have to do is you have to write escape packet, and notice that the export and deport are both on the TCP layer. As you can see, export and deport are both on the TCP layer. So we need to first access the layer by doing escape dot TCP. As you can see, escape dot TCP, and the field name that we are looking for is deport, and this is the deport. And we are going to say that this file is equal to 80, which is HTTP. So when you are looking here, you will actually see that HTTP instead of 80. So in our code we are going to be using HT80 instead of HTTP. So if the destination port of the TCP layer is set to 80, then this means that this is a packet leaving our computer to a destination port of 80, which means that it is a request. So we are going to print this request, and the HTTP request that will print the packet show. So now we can add another condition by adding elif, and the second condition that we are going to be use when we are going to check again. So the escape dot TCP, and this time we are going to check if this is S port. So the source port is set to 80. Then this is a packet leaving from the HTTP port and coming back to us, which means that this is the HTTP response, and then I'm going to print the packets that were captured, and if it is request, then it will tell us that it is request. So if it's response, then it will tell us it is response. Now I could literally wrote program straight away, but I wanted to start from basic, so tell you how this is actually works, so that you have a basic understanding of this code, so that you see the process of how you should analyze packets and use the fields to extract the useful stuff to you. So that's it for now. In the next lecture we're going to run the program, see what happens when someone download a file, and see how this program will be very useful to analyze this data and build for a larger program, which we will replace the download file with any other file that we want. Okay, now that we built and tested our program against our local machine, so in this lecture I am going to show you how we can use this in a more realistic scenario against a remote computer, and we replace the file that they download with something else that's useful, and we'll replace it with a like credential harvester. Now running this against a remote computer is identical to running the DNS spoofing script against a remote computer. So we will have to run the ARP spoof first, but to get in the middleman. So the IP table rule that we use, what we want to redirect that packets coming from a remote computer, not local packets. So then we will run our script, and it's very simple. It will show you how useful this program is. Now before I do that, I spent a couple of time to just simplify my code. So previously, if you saw my lecture, as you see, there was a lot of many complicated lines. So what I did is I just simplify my code, so for the better use of us. And I think this code looks much nicer. Like if you have a function, for example, that called set, so set underscore load, and I can pass this to the escape package to it, pass the load right here. So whatever I want to set the load on which all strings, that it will do everything for me. So as you can see, I call the function by, but I actually as you can see, I also define the function as well. So it's telling me that it's an solve references. So if you check my previous code to this one, then I think you will notice the difference. Otherwise it's hard to tell. So just copy this. In my previous lecture, a couple of lines were under this, so I just copy this to this, and I just rename all those escape packets. As you can see, there is no escape packets in here, so all of those turned into a packet. And then what I did is I defined the process packet in here. So I defined two So as you can see, do function. So I can just minimize this just to focus on the code. So if I wanted to extend it and do more stuff with it, I can also do that, but now our code looks pretty good and I'm pretty happy with it. So if you go and test this on a remote machine, what you have to modify now is I have to modify an completely different file that I don't want to serve this same file. Previously I served a WinRAR file from a website, so now what I'm gonna do is I'm gonna serve a file from this machine to the target who will download something from like WinZip page. So what I did is I just specify my location. As you can see, this is the location of this exe evil underscore or evil file exe. So I just specify this because what this will do is when someone download unzip or from a vulnerability site, it will download this file rather than downloading the original file from the website. So I have that already stored in my web root. So remember I said in Kali machine it comes with a server. So just go to this location and create a file, and this will send to the file. So just then what you're gonna do is just click this and make sure you type all this right. As you can see, there is no error in my code. Now what you're gonna do is you're gonna run this program. So first you have to start your Apache to database. So first just start a database, then you have to flash your IP networks, then because then you need to run the IP tables rule that we use to redirect data coming from the remote computer. So flash to remove everything from our IP tables, and then we usually run the output and the input. So we redirect the data coming from the input and the output chain when running on a remote computer. As I explained before, we do this to accept like a chain or as usual. So there is a number of ways to become a man in the middle. I actually explained a few of them in my previous lectures. So becoming the man in the middle using ARP spoofing, and we built a tool that allows us to do so. So what I'm gonna navigate to my tool, which is the directory of ARP spoof, and then just run your Python code. Then this will put me in the middle of the connection. So make sure you run this code perfectly on your terminal. So what this tool will do is it will replace .py or the Python file into a evil file that we selected typed in our as you can see this file. So what I will now do is you go to the page, you go to this page and press download or press in here. What will this do will it will showing me that as you can see evil.exe, this file will be downloaded. As you can see, this file will be downloaded. So if you run this file on your Windows machine, as I cannot do that because I am on my Kali Linux machine, so it cannot really initiate this exe file directly. So what if you send this file on Windows, then what it will do is, and if you run, otherwise it won't work. If you run this file, it will give your security permission from your Windows. So make sure you disable the security before saving this file, because otherwise you cannot save this file. So if you run it, so what it will do is it will save a text file, and it will save a username and password that is stored on those machine that you downloaded this file on. So it will save a password and username on those machine that will be vulnerable. So then you will be managed to do this without sending the target anything. The target willingly went and tried to download, will then do this automatically, and you will get the username password if that is stored in their machine. So that's all about replacing download on the network. So now that we have a program that can filter HTTP requests and responses, let's use it to analyze and see what happens when a user clicks on a download key. So what will happen, and how we can use this information to hijack this download and server user any other file that we want. So what you have to do now is you can go to any page like WinZip or any page to go and go to the download section. So before that, what you have to do is you have to clear your browser history. So just download a zip file or something like that. So when you click on the download, and that will be the HTTP website, not HTTPS website. So that will only work on HTTP for this code. So we will talk about HTTPS later of the lectures. So when you click download, is going to download, and it will run some code on your machine, on your terminal, or which. So the first request should be download request. So as you can see in here, I screenshotted this code, so that screenshot not all of the part, there will be all of the part in upper side and the lower side, but I just screenshotted the main part that we want. So basically what's happening in here is specifying the host, which is the domain where the file is going to be downloaded from, and which is in here. So it's also specifying the file or location of the file on this domain, as you can see on this domain in here. And so basically if you combine this, you will put domain and put followed by this is actually a URL where zip is going to be downloaded from. So you can literally copy this and paste it to any browser, and you will be able to download it. So for now and for us to detect if the user is downloading a file that we want to hijack, we can use the value and check if the load contains anything like .exe. So I am going to go back to my code and type these two lines. So we will talk about this line and this line. So and I am going to go where I am detecting a request. So I am going to go under this, and I am going to add is a if statement line. So if statement, I am going to say that if .exe as in my escape packet, and access the load by doing a escape.row. So we are accessing the row layer, and then we are accessing the load. So basically what we are saying is if exe is a field that of the raw layer, which is basically in here. So if you see a .exe, that means that I want to hijack this, then I want to run my code, and then this is the if statement block. So first of all, we are going to print the exe request. Then as you can see, we are going to print the exe request. So just type these two line. We are just talking about these two line, and others are the pretty much the same that we previously described. So that will replace the file. So basically using the exe as a keyload or a trigger our code to hijack the files. So if you are targeting if you want to replace PDFs, then you can change the exe. So you can just simply change the exe to PDF or any other extension that you want. So if you want to replace images, you will use the image extension like JPEG or JPEG or DNG, etc. So if you want to replace any other file, just use the file extension in here, and you can also trigger this code based on anything else that you see in the load. So it all depends on how you are going to analyze the packets and depends on your goal. So this is perfect. Now we are able to detect whatever the user tries to download an exe, so that we can execute any code we want. So right now you might think all we have to do is replace the host in here to any host that we want to replace the URL. So here in this URL you want that you can change any URL that you want, or and then you change the URL that you need, then we will be able to replace the file. But unfortunately it's not as simple as this. You can do this, but before you can modify request and send request, you are going to have to manually initiate a TCP handshake. So you are going to have to do that first, and then you can serve the target other files that and target other files that you want. There is a simpler way though. Now we are able to catch the request and responses. As you can see, we are catching their request for the exe or the target file. So we can wait for the response and modify this response. This way the handshake has already been established, and therefore we can modify it without creating or establishing an handshake. So in the next time I am going to show you how we are going to modify the response and successfully replace downloads from any computer that is connected to our network. So in our program we are able to intercept download of a specific file type, and what we are doing so far is we are printing for the download request and responses on the screen. Now in this lecture I want to show you how we are going to able to successfully modify the response, so that when the target requests a specific file type, we will serve them a completely different file. Now this can be like Trojan, backdoor, anything that you want. So going in here, this is the code. When you run this will when you run the Python code, and this will show up. You will get the HTTP request and the result. So as you can see in the responses, it's saying that this is the responses. So it's saying that the load, which is the part of the useful for us usual, it's saying that it is given like 200. As you can see, this means basically it can serve you the request. So the request was the exe in here, and download the unzip file, and basically to server is basically server is saying that you can I can serve you this, but you will see some HTTP headers after that. Then you will see that you will have literally a hex code in here. All of these are hex code in this line. which contains the exe. So this is literally the content of the WinZip file, and that's going to be downloaded on the target. So if you pay close attention, you will see that there is nothing in here, and that tells us the response contains a winzip.exe and it's a response for an exe file. So that's how you know this response is made for the request. As you can see, because as we know, there are lots of requests and responses sent on the network. So sometimes maybe you click on one link, but there is a lot of requests and responses that being sent in the background to serve you that link. So what you need to way to know that the response right here is corresponding these response. As you can see, these are similar, as you can see. So these two fields, so you can, so we need a way to know this response right here is corresponding to that response. Now in order to do this, we are going to need to pay attention to all the fields in here. If you look at the act in right here in the request, now in order to do this, you have to look in the sequence. So you will see that they are identical. As you can see, they are pretty much identical, and this is how packets are associated with each other. And when this request was sent, it has this ACK number, and then when the server responds and response and that response, the TCP layer is going to create a field that called sequence, and it will put the same number that it received, and this will act as the sequence number. So this is how the system knows that this response corresponding to this request. So it checks if the sequence corresponding to the act. So we can use this same mechanism to check if the response corresponding to the request. So what I'm going to do is, we are going to go back to our code. So let's go to our code, and so I am going to have to do is, first I have to create a blank list or ACK list in here, and which will have to do is, which will have to keep this list empty. So just type this and put two brackets, and you will understand why I am using this list in a minute, but let me go through it and it will become more clear. So the reason why I am creating this list here is not inside this function, because you know the function, the process packet function get, then the function the processes, that function gets called every time when you sniff a packet. So if you declare a variable like this one, and that will initialize, after that you initialize, and this variable will create and initialize every time this function get executed, which means every time we sniff a packet. But if you create it in here, this will only be created and initialized once, and we will be able to use it throughout this program. So I am creating an empty list in here, because my code already detects whatever I have an HTTP request, it will also check. So if the request is .exe, a file that will have more .exe extension, so once I detect that, I am going to print, and I have an exe request that will print also. I am going to append this list. So you can add elements to list by putting the list name followed by dot append. So as you can see, so this is the app list followed by a dot append. So now this is a method that allow us to add element to a list, and the list name of our list is, all we have to do now is put the element that we want to add into the list, because between the bracket and the element that we want to add in here, that will act of this packet, because this is a request, as you can see. So basically what we want to do is, we want to add this right here, so that after adding that we will have the access of this TCP layer and access of this field. So we are going to put the packet name, which is scapy underscore packet followed by a layer of the name, which is scapy.tcp, and the field of the name is ASIC. So now every time there is a request that contain .exe, they are going to be stored in my data, because we are using the append method and the next if statement. So we are gonna if statement in here. So what we already have that checks for the responses, as you can see. Now what we are going to do is, we are going to use another if statement, and in this if statement we are going to check if the sequence. So as you can see, we will check if the sequence. So we are going to check if these fields right here contains in my list. Again, note the sequence in here is the same as the AXE in here, as you can see, if pretty much similar. So if the sequence here is contain my data, this is a response that will send, and that I am interested to our scapy to capture this at least. So if statement in here, so again we are going to have to access the scapy packet, then the TCP layer. So scapy the underscore bar packets and scapy.tcp, and this time we are looking for the sequence that we are going to say, and this is my ACK list. Then I am going to print this statement using this replacing file. Then we are going to put this code, and we want in here that we want to replace the download. So as you can see, this is replacing the download. So now I don't need this print statement right now, so just delete, and this one also. So we are done. So we are doing in whatever we detect a request, and that's the interesting to us. So we are gonna store a ACK field, and to the list, and that's called a list. And then in our response method, or in our response block code, we are going to check if the sequence of the current response is in my TCP. So if it is, then we are going to replace it, and we are going to put all the code that we are going to replace. So to use the replace file in here, what you have to do is, since we have detected that the sequence is in the list, and we are going to replace it here. So we should actually, as previously, we should always remove the sequence from the list, because we are not going to use it anymore. So in order to do that, we have to use this remove function to remove an element to the list. So we are gonna use append, and So it's exactly this one. So this will remove all those escape packets or escape .tcp. So that's the method that we can use to remove, and we are going to put the element that we want to remove. So in my case is exactly this one, escape packets. So we are using the list name followed by .append to add an element to the list. So then we are using the list name to remove the element from the list, and that's it. Now this is the full code, and our code or our program now detect if the target is downloaded a certain file, and then we can also capture the request from the corresponding to this request. So just run this code on your machine after typing all this code, and what you will get is you will get similar like this. So you will get is like a exe request. So on display it will display the request and the response that is sent to the user. So we are getting a .exe request. So where we don't have that much data like from previously, but we'll get into this. So you can still see that you will get exe request, and we are seeing how we are seeing the show that the request, and we can see that the replacing of the file, and we can see the result of the responses. Now in the next lecture we are going to analyze this response and see how we can modify it so that we can replace the file with any other file that we want. So now our program is able to detect requests that are requested like download and exe. So it was able to detect the request from the corresponding request and that everything on the screen. So if you just run the program and download the file, and if you try to cancel it, you will see that the first detected request here, that will be request.exe, and then you will get like response. So which is like telling me that it's replacing the file that I have in the content for the response packet. So as you can see here, this is the response file from our run code. So and our goal is now to identify the response. So we're gonna serve them to any other file that you want. When someone, instead of downloading the file, we will download a separated file from the victim machine. So as we see and spoke about the previous lecture, we said the part where HTTP data is stored or transmitted into the load, and this is the response. And in the load we can see that there is a 200 OK. So the 200 OK here is actually a HTTP status code. So there is a number of these codes. So this can be returned as response, and in order to manipulate this packet, we need to learn a little bit more about this HTTP response. So what I'm gonna do now is we're gonna detail look at those HTTP response. So this is the HTTP status code. So grow just a simple Google search will give you the result of HTTP status code from Wikipedia, and that this page explain really good. So this page shows a list of HTTP status code, and you can see that the code we are getting right now is 200. So which basically means that I can give you the things that you requested, and then you can see that in here it actually have that contents of a file that transmitted in hex. So what you want to do is, we don't want to say that everything is okay, we actually want to give a completely different file from the file that we target request from a specific site. So if you go and spend some time and looking through the status codes, and if you scroll down, if you have a like 300 status code to redirect this client to somewhere else, and this one, what you want to use, this one is 301 move permanently status code. So go to this link. So if you see the description of this status code, and it's a page which will give you a lot more information plus an example, this one. So it doesn't get any simpler than this. So you can see this is the response. We are getting a 301. So previously in our code you are getting a 200. So in here we are getting a 301. So instead of 200, the name of the status code is moved permanently. Then we are going to specify the location which contains the file, and that we want to redirect the client to. So what you have to do is, you just copy all of this and paste into your command, into your code that we previously typed. So let's run our code, check. As you can see, we paste this file location. So we are going to have to first access our scary packet raw layer in the packet. So we are going to say that escape packet dot raw. And so as you can see, escape dot raw. Now we want to modify this load of this packet, and we are going to say that is equal to whatever. So I just copied and paste this in here, and I can use all the method that we can use to string, or I can just make it equal to a string. Now keep in mind that the way that is a response should be sent is aligned in a new line, and then location. So you have to type /n or \n before the location. This will basically mean that I have this in my first line in here, and this is the next line. Then I have a new line character, which will basically mean I am going to go down one line, then I have the location now. Or you can just, if you want to fill the paragraph, just type this, it will fill it into a next line. So what you have to do is, you have to replace the exe file of the client that we download with another exe. So you can use any backdoor, you can use any credential or harvest or anything you want. So we are going to use this website to replace the file. As you can see, this is the RAL file website. So instead of they try to download any file from like any website like WinZip, they will download this file instead. When I click download, they will download this file. So they will get this exe instead. Now that's perfect. We have modified the relevant part of this packet, which is the part that contains the file. But just like I did in the DNS spoofing lecture, that we need to remove the length or remove the field. The checksum is the IP and the entity layer, as you can see. The reason for that is because we modified the packet, so the value in here should change. We can calculate the manually, but we can just remove or just escape. So you will automatically calculate the value in here for us. So this is very similar what I did when we doing the DNS spoofing lecture, and you would want to do this every time you modify packets. As you can see, we done couple of times. So we are going to do a del escape underscore packets and access the IP layer, and we are moving the len. So duplicate this line, then just remove the checksum instead of lem and then checksum, and then call cell from the TCP and checksum from the TCP, and it will be all done. So we remove all the fields that we need to recalculate and escape. So it will automatically recalculate for us. So and finally we have modified the package and we have done all those stuff. So what we still didn't modify is the actual packet that we will send to the target. So what we are going to do is we are going to escape packet, which is literally just a variable that used in the function. So if it's not sent, so again this is exactly like what we did in the DNS spoofing program. We are going to do packet dot set underscore payload, and we are going to set the payload to this string of this escape packet, and which is str. And I actually explained this is the DNS spoof lecture that, but basically we are converting the packet that we are getting in here to escape packet in this line. So we are going to analyze it and modify the way we want, and finally when we are done modifying, we are going to first convert this escape packet to a string, because as you can see we converted it to a string because this method expect a string, and then we are saying that this packet that set payload, and we are passing it to the packet that we modified, which is escape packet. Now just save this and test this code. If just run this code on your terminal, so what, and then visit the, so when you download and when you run this code and visit this page, so when you click to the download website and click the link, it will download a completely different file. As you can see, this is the WinZip file, WinZip website. So it will download a WinZip 22, but instead of it is downloading winrar56b1.exe, so which is this one, as you can see. So winrar56b1. So this will be downloaded and you can access it from your download folder or where you download. So that's actually shows that our attack actually works. So you can use this, or and we'll see we can use this to change the download file using just simply this 5 line. So make sure you type this right. Now in the next lecture, again we'll try to test this, see this in the next lecture in any computer. So once you become the man in the middle, and you will be able to replace any file that they request to download with any other file that you want.